Hello, fellow cheat hunters. Today we're going to be doing pointers. So first things first, you need to find an address. Now, as you can see, I have already set up. We're going to be doing Zenny. It's probably one of the easiest things to find. So first things first, let's go over a few programs. I'm using system DVR to post from my switch to the computer. I'm using NoExs from Tom Switch or Tom Vita. To use this, we're going to be using network. You can use USB. I find network's a lot more stable. So IP address, you're going to find your PIDs. Usually it's going to be one of the bottom ones. That's going to be the title ID for Monster Hunter, so you're going to attach. And here's our memory allocations. The important ones to know are heap and main. All right, that's going to be most of your code there. Main is going to be for your standard items, so things that are game code, things that should probably not be changing, and where your pointer is going to be. Your heap is going to be where all the game data is, pretty much. Everything from where your position is, your attack values, just about everything is going to be in heap. Now that we're attached, we're now going to do a search for our values. So I already know my value is on NoExes, you need to make sure you're doing hex. There's a useful little button right here. Make sure you're using it. All right. It's no value. It's going to be equal to this. There's your expression. Search. Now this is going to take a while. So while that's going on, I'm going to be going through the other programs. Here's your PointerSearcher, another Tom Vita special. This is going to be how we're going to find your pointers. Now, that being said, technically, NoExes can find it. It does have the capability, but I find this highly unreliable. It likes to throw negative values and just a bunch of stuff that's not going to be useful for the switch. So we're going to stick with PointerSearcher. This same thing, we'll be able to attach it. We're going to dump the memory into the hard drive of the computer. And then from there, we'll be able to search and find the exact codes that we need. All right. Over here, we're going to be keeping track of all the information. This is going to cover any values that we find or addresses that we need to hold, and it's also going to put our pointer references, so that way we can make sure that we keep a copy of it in case anything goes wrong. So I'm going to skip forward and let this finish. All right, we are back. So we have the search results. As you can see, we got 4 results. A couple of things to remember, that some of these can be hidden values, some of them can be false positives, and some of them can be stuff that's not even related to what we want. So real quick, I'm going to make sure I poke these to check to see if they are the correct value. Bam. So I added 5. Zenny went up 5. So I know this is my value. So I'm going to go ahead and put this in the watch list so that way I can keep track of it. Now, we now know what our address is for this current session of the game. Now, every time you, say, restart the system, you load a game for the first time, not a resume, but an actual close out the game and start it over, these values can change. So right now, I can use this all I want to change my current Zenny. But in order to create a cheat, we need to find a pointer, something that's going to point to the exact address every single time, because the addresses change based on how much memory is available, what programs are running in the background, all dozens or so factors. So we have our address, and we are now going to start using PointerSearcher. First things first, though, is we got to disconnect NoExes. The client is trying to pull that information from the switch, and so we can't use a second program that's going to pull from the switch using the same system app that the first one's using. So let's go ahead, disconnect, and let's go ahead and attach this. All right, everything looks good. So we're going to go ahead and dump this. And what that's going to do is it's going to make a complete copy of the game state as it is right now to the computer. All right, this is going to take a little while. Same thing, it's going to be dumping almost 3 gigs of data. So this bar will refresh a couple times, and then you'll see it slowly go up. So I'm going to go ahead and stop again, so that way I'm not wasting your time. So first things first, we now have a full copy of the game into our pointer searcher. Now, the other reason why I prefer pointer searcher is because it's going to pull these values right here, both your main start, main end, heap start, and heap end from the Switch console itself. If you are doing a manual search where you create a dump through either some type of third-party program or whatever else, you cannot use the NoExs Client to transfer. For example, like I can do a memory dump, all right? When I did the first search, it grabbed a memory dump. That file is not compatible with Pointer Searcher. Made by the same guy. I don't know why he did it different, but our concern right now is we have the file. It's in there. To start, we need to find out what our target address is. Now, we established that, so we're going to go ahead and throw that in here. All right, now this is set up, so we're now going to go down here. These are the default values. They are usually correct. All right. I usually don't have to change this too much. So let's go ahead and read the first dump. This usually just takes a couple of seconds. All right. So it's read that data now, and we are going to reset and search. All right. First things first, we now have a list of pointers. Now, a general rule of thumb is the more pointer offsets there are, the less likely it is to work. That's not always true. Sometimes you'll find some that where like this is a 2 offset. This won't work, but a 4 or 5 offset will. So this is where it gets tricky. So usually what I do is I just take all of these, bam. Okay, I have a copy. I don't have to worry about it. Now, I could cheat and sit there and go, well, I can already tell some of these are not going to be as good as others. All right. But the key point to look at is here we have a plus 58 and a plus 18. Oh, plus 58 plus 18, plus 58 plus 15, or 18. All right, great. These all are referencing something very similar to each other. That being said, some of these are a little different. You know, we have a plus 20, a plus 28, you know, and then it starts getting, with a fourth pointer, it starts getting more crazy, right? These two, I'm not sure these would work. These are very different than everything else, right? So the biggest takeaway is realize that some of these may not work, but we're going to go ahead and try a couple of them anyway. How you check these is you take this, copy it, and we're going to have to disconnect this so we can reattach here. Now, since I haven't closed this out or I haven't changed anything, it is still attached to the process. It is still golden, right? Down here in expression, we're going to paste that and we're going to parse it. Okay. So this one did, in fact, give us the correct address. All right. So usually what I do is if it works, I bring it down to a separate list. Take this one. This one works. And you can do this for a bunch of them. All right, so these are all pointing to the correct place. But this doesn't actually tell us the real value. All right. This is just what's working in this current dump. Now, if you don't mind spending extra time, you can create a second dump by closing out the game and dumping it again and doing this whole process. That's I tend to find that works better on games that are really difficult to find addresses to. If you're really struggling to find addresses, it's almost better to save one whole set, go back, create a second whole dump, whole new set, and find the pointer that way. Because what this is going to do is this is going to narrow down this list. Because as you see, some of these codes aren't going to work. All right. So what I'm going to go do now is I'm going to stop. I'm going to turn off my switch, reset it, bring up Monster Hunter Rise again, and then, we'll do the same thing. All right, we are back in the game, so let's go ahead and let's find our new values. All right, as you can see, our PID changed. So again, make sure you're getting the correct ones. Otherwise, you're going to be wasting your time. Also, our heap and our main changed by quite a bit. So that's good. This will show you exactly what I'm talking about when I say that, these values are dynamic. You can't just say, oh, go to this address, because it could change simply just by restarting your game. All right. So let's go back, search. We want our Zenny value again. And again, we're going to be dumping in another 3 gigs almost. So I'm going to go ahead and pause. That way I'm not wasting your time. So our search is now complete. As you can see, we have our values. Now this step was completely unnecessary. I'm just doing this for demonstration purposes. And your first couple of times doing it, I would kind of recommend it, just that way you get into the habit of making sure you are getting the correct values. Now, as you can see, we're back up to 4 addresses. Do we know which one is which? Well, yes and no. With experience, you can start seeing some trends. Now I want you to take a look at this address and the address that we know is our previous one. They have something in common. FD8C8. FD8C8. I can almost guarantee you this is the address we're looking for. All right. That's just experience and knowledge and stuff like that. Like, don't be trying to do this on your first try. That's a good way to make a mistake. What I would recommend is, start poking these. Okay. We know that. All right. We know that, this is our value. Well, great. Let's poke this, and 1, 2, 3, 4, 5, which should go up 5. Yes, it did. Perfect. So we know this is the correct address that we want. All right. So we're going to go back to tools. Now we have these addresses over here. Now, if you remember correctly, I stated that this was not going to be a good one. Again, this is just experience talking, but we want to check it anyway. So we'll go ahead and put that over here, parse it, up, exception error. Pretty much what this is saying is, yeah, this is not a good valid address. All right. Nothing came up here. It threw an error. We don't want this. So this, we can just get rid of. All right, what about this one? This one could be good. All right. Did this go to the correct address? Well, is that the same? Yes, it is. So technically, this would be a good pointer. But like I said, you always want to go with the least amount available. So we're going to go ahead and use this 2 offset. Oh, look at that. It also goes there. Why this is important is when you start creating the codes, this is going to be more work the more offsets you have. It's not a whole lot more work, but it's just extra lines. And if you can get away with less lines, the better. Currently, if you use Edison for your cheat manager, it doesn't like more than, I think it's 10K lines. So you're really limited on, how much you can put in. That being said, 10K lines is still a ton of lines. You'll get some games where there'll be only 2 or 3 cheats, and there's no way they can get up to that many. But as some of you are starting to see with the Monster Hunter Rise, well, the server is doing an incredible job finding these codes and getting some really valuable cheats. Well, the master cheat file is getting pretty damn big. We haven't quite crossed that threshold yet, but we're getting pretty close. I expect with 3.0, we may actually cross that boundary, especially if we can find some more interesting values. But that being said, less lines the better. All right. So we know this is a great offset. So what we're going to do is we are going to use this one. And these I no longer care about, but I'm going to keep them on screen for everybody else. So here's our pointer. All right. To break this down, what this is doing is it's saying, hey, in the main, add this value or start at this address and then add these offsets. All right. And that's going to point to a very specific address, regardless of where it is in memory. I really don't want to say it that way. Regardless of what memory is allocated. All right. Like I said, for our previous session, our first session, our heap started at 17 CAE. All right. Well, in our current one, our heap started at 3D 46A. Well, whatever code we got here is not going to work in this address. It doesn't even go that high, right? Or I should say, this is higher than this. So whatever we do, we are never going to be able to use a code from this session to this session. But with a pointer, what we're doing is we're shortcutting it. We know that the memory address is going to start here, right? So what we do is we take this value, which technically there's a 0 in front of this, but it's hidden because we don't want it. But you'll see that here when we start working on the cheats. This starting address is based on a 0 value at the start, all right? So if we have a 0 D8, D9, this, all right? And we take that from the main, right? And then add these 2 offsets. We will always get to whatever address is needed to find this Zenny value. So what we're going to do now is we are going to create a cheat. Now I went ahead and took the master file and the Zenny value, which is why you'll see this. Now, a couple of things. If you notice, oh, this looks familiar, doesn't it? Well, that's because that's this. All right, right now, ignore these first lines. These are code types and basically how Atmosphere is translating this data into usable code. So we're not going to go over this. We'll go over that in the next episode. All right. But important things is this first line. This is the reference address. All right. That is this. This copies directly over with a 0. All right. If, for example, I should mention this is 8 digits long. All right. This is 7. If you have a pointer that is 8 digits long, you might be doing something wrong. All right. It's probably an invalid pointer. I don't think any of these, yeah, these were all valid numbers, but yeah, if you get, I saw somebody post a cheat that had, I think it was 11 characters here, and there's no way that cheat will work. It's impossible. The issue is it's probably going to overflow the memory, and that can cause either the game to crash, the switch to crash, or the code just not accomplish anything. But generally speaking, we want a 7-digit code here. All right. Again, 0, so we make it a nice even 8, and that helps Atmosphere understand it. And then the next 2 lines are going to be our offsets. All right. So as you can see, 58, 58, 18, 18. Perfect. Now this last line is what we are changing the value to. All right. So this is for 10 million. Now if we throw this into a hex to decimal calculator, which if you're using Windows is actually quite easy. You just go down here, programming. We know this is a hex value. We post it in here. We go to decimal and 10 million. Nice and easy. All right. And you can do it back and forth. So if I want to change this to, let's say, 750,000. All right. Here's our new hex. So we could drop this into here, again, making sure this is an 8-digit code. All right. So we did lose a couple digits here. And make sure it's not spaced. 4, 5, 6, 7, 8. Now this would be money. 750,000. Perfectly valid code. Okay. Like I said, we'll talk about code types and how to break these down in the next episode.